Let us talk about this problem. We are given two strings s1 and s2. Our task is to find out whether string s2 is a subsequence of s1 or not. We are going to return a boolean value. We will return true if s2 is a subsequence, otherwise we will return false. Let us first quickly define what is a subsequence. A subsequence of a string is obtained by removing 0 or more characters. And whatever characters we pick, the characters that we don't remove, we need to put those characters in the same order as they appear in the original string. Let's understand with this example. ABC, its subsequences are empty string. We have removed all the three characters. A, we have removed BC. B, we have removed AC. C, we have removed A and D. AB, we have removed C. But A and B should be put in the same order. Please note that BA is not a subsequence. AB is a subsequence. AC is a subsequence. We have removed B. And this is where we note the difference between subsequence and substring. Substring means contiguous characters, right? Here we don't need to have contiguous characters. We may remove characters from the middle. BC is a subsequence. We have removed A. ABC is a subsequence. We have not removed anything. The total number of subsequences in a string of length n are going to be 2 raised to the power n, right? You can notice that if you have a string of length 3, then there are 8 subsequences. And the reason is simple. For every character, you have two choices. Either you keep it or you don't keep it, right? That's how you are going to get 2 raised to the power n subsequences. Now, please pause this video. Try to write down a function that takes a string s1 and another string s2, returns a boolean value, returns true if s2 is a subsequence of s1, otherwise returns false. So now we understand subsequences. Let's take a look at the examples. In this example, ABCD is our s1 and s2 is AD. AD is a subsequence of ABCD. We have simply removed BC. Now if we see this example and this example, AED is not a subsequence. See, if you remove BC, the order that you get is ADE, but we have the order here AED. So AED is not a subsequence. The characters should be in the same order, right? So now please pause this video and try to write down a function that takes two strings as input, s1 and s2, and returns true if s2 is a subsequence of s1. A naive solution to solve this problem is to generate all subsequences of string s1. There are going to be 2 raised to the power n subsequences, and then for every subsequence compare it with s2 and see if any subsequence matches. As soon as you find a subsequence matching with s2, you return true. The time complexity of this naive solution is going to be clearly upper bounded by 2 raised to the power n into n. See, n is the length of the larger string, and since I am using big O upper bound, I can use n here as well. Although we are going to compare the smaller string with every subsequence. If you want to be more precise, you can put the length of smaller string. So this time complexity is actually exponential, and we can do much better than this. Please pause this video and try to think of a better solution. Let us now talk about idea for the solution. We are going to use two index variables I and j for both these strings. And now what we are simply going to do is we are going to compare s1i with s2j. If the two characters match, then what you will do, you must have guessed it. You will move ahead in both these strings, because we have matched this character, we have found this character in s1 in the same order as it should be in the s2. Right? And if they do not match, then what we do is we simply move ahead in the s1, because this character is of no use for us. See, it might be appearing somewhere later, but we are looking for the character R now after we have matched G, right? As long as we don't find R, we would not process any other character, right? Because the order of characters in the subsequence should also be same. So we begin with GG, they both match, right? So we are going to move ahead in both these strings. We are going to come to E here, and we are going to come to this R. Now these two are not matching, right? Although E is required here in S2, but we are looking for R now, right? So we'll move ahead in this string. Now E and R again not matching, so we'll move ahead. We'll keep on moving ahead and we'll stop at this point, right? So we kept our J here and moved I to this point. Now they both are matching. Now we'll move ahead in this string. Now we'll compare and we also move ahead in this string. We have I++ and J++. Now we'll compare G and G, again matching, so we'll move ahead in both these strings. We'll come here and we'll come here, right? And we'll compare E and D. E and D are matching now, so we'll move ahead in both these strings. So we come to S here and we come to this E here. Now we compare S and D, they are not matching. So we'll move ahead only in this string. Now again not matching, so we'll move ahead in this string. We'll come here. Now they both matched, right? So we move ahead in both these strings. And when we reach end of these strings in any of the two strings, we stop our running the loop, right? And if you have reached end of S2 also, that means you have found all the characters in the same order in S1, you will return true in this case. But if you have only reached end of S1 without reaching end of S2, right, then you will return false. Now you have complete idea about the logic, intermediate steps inside the loop. Please pause this video and write down the solution yourself. Please write down both iterative and recursive solutions. We are first going to write down an iterative solution, then we'll discuss a recursive solution. Let's now take a look at our iterative implementation. We have two variables j and I. J is for indexing S2 and I is for indexing S1. And the code written here is close to C++ style. In Java, you can simply use boolean instead of bool. Also, if you're programming in Java, you need to use capital S here for string. And if you're programming in C++, then you can slightly optimize it by passing it as a reference, right? This will avoid copying of S1 and S2 when we pass them into a function, right? And in C++, it's again a better programming style to use const also, right? When our function's intention is to never modify the string, right? So we can use ampersand and const both in the function if you are programming in C++, right? And if you are programming in Java, we simply need to use capital S and boolean here. So we begin with j equal to 0 in second string and we begin with I equal to 0 in the first string. So instead of using a while loop, I've used a for loop here because I is always going to be incremented, right? The conditions that we wrote, I was always being incremented, right? So we are simply traversing through string S1 and we have this condition that we should not reach end of S2 also because we are going to compare S1i with S2j. If they are matching, we are simply doing j++ and we are always doing I++. And at the end, I have written some short codes. I have avoided if else condition. This line means if j is equal to m, then return true, otherwise return false. So that's the simple idea. You run a loop for this string, right, S1. You have index j for this string. If I and j are matching, then you do j++, and I is always incremented. So a and a matching, we do j equal to 1. I is incremented to 1, right? So this 1 and this 1, they are not matching. So we'll do simply I++. I will come here. C and D not matching, so we'll do I++. Now these two are matching, so we'll do I++ and j++. J will become 2. Now again they are matching, so we'll do I++ and j++. J now becomes 3, right? So j is now equal to m, so we'll come out of the loop because this condition becomes false, and j is equal to m, so we'll return true also. Now talking about the time complexity of this iterative solution, this solution is clearly big O of m plus n, and auxiliary space required is big O of 1. See, why am I saying big O of n plus m? Somebody can pass a larger S2. In that case also, it's going to run this loop, right? And we can do slight optimization in the solution. For that particular case, we can have a condition if n is smaller than m, then we can immediately return false. That's an optimization for some cases, right? Where your string length S1 is smaller, right? Because if S1 is smaller, then S2 cannot be a subsequence of it. So this is our iterative solution. Now please pause this video and try to write down a recursive solution. See, recursive solution is not going to be better than this. It's just a recursion exercise for which I am asking for you to write this recursive solution, and I am also going to write the recursive solution. Although iterative is better, recursive is going to cause extra space and extra overhead. Here is a recursive solution, and in the recursive solution, we are matching last characters instead of first characters. I am matching n-1 and m-1th characters. See, if you match first characters, that solution will also work. But if you try writing that solution, then you will have to get the lengths first, or you will have to pass 2 extra parameters for indexes, right? here we are already passing lengths of the strings. So using the lengths, we can always get the last characters and we can pass updated lengths in every iteration. That's why we are matching with the last characters, and that's generally recommended practice for recursive solutions of strings or arrays. We begin from the end so that we can use the length itself as an index and we can keep changing the length. So n and m are passed and we are passing, comparing the last characters, and the last characters are matching. We are calling for n minus 1 and m minus 1 like the iterative solution. And if they're not matching, then we are recursively calling for n minus 1 and m. It's again similar to iterative solution. And here are the base cases. When you are reducing n and m, one of them can become 0. So if m becomes 0, it means your other string, the smaller string, has finished. So you have found all the characters of it in the bigger string in the same order. So you return true in this case. And if n becomes 0, it means you could not find all the characters of second string in the first string and your first string finished. So you return false. See, the order is important. If I put n equal to 0 at the top, then it might give you incorrect results. For example, it will give you incorrect results for this example itself. Both of them become 0 here and we should be returning true. So let's take a look at the dry run that we have written here. A, B, C and AC are two strings. 3 is the length of first string, 2 is the length of the other string. So we compare the last characters. We reduce n and m by 1. So we have 2 and 1. Now we compare the last characters at n minus 1 and m minus 1, which means we compare B and A. They do not match. So we reduced n only, we don't change m. Now we compare A and A. They are matching. So we reduce both of them. Right? And now we have 0 for n and m both, but we check for this condition first and we return true. So this function call is going to return true its parent, and its parent is going to return whatever the called function return, and the parent is also going to do the same thing. So we get true from here, right? And this also returns whatever this returns. So it's going to return true, and this also going to return whatever its parent return, its child return. So it's going to return true, and it's also going to return true to the main caller. So this way we get the output as true. And again, please note that if you're implementing it in C++, then please use ampersand here for optimization, and for better programming use const also in both the places, ampersand const. And in Java, we need to use boolean here, we need to use capital S here. Also, indexes characters at indexes n minus 1 and m minus 1 are not accessed this way in Java. I forgot to tell in iterative solution, in Java we need to use char at, right? This is the syntax in Java. We call a function char at on the strings to get the character at index n minus 1. Similarly, we need to use char at here. Now talking about the time complexity of the solution, it's same as the iterative solution, just that we have written a recursive solution. So time complexity is big O of m plus n. In fact, auxiliary space is also m plus n here, and this is where it's not good as the iterative solution, right? Iterative solution requires big O of 1 auxiliary space. Here we have recursive calls, so we need big O of m plus n auxiliary space for function call stack.